Hello, welcome back student. Today we are going to see the Epsilon NFA and conversion of Epsilon NFA to regular NFA. Okay, let's go. Here in the last class I did not completed this diagram, because of that I draw here. Here the finite automata FA. Finite automata is like finite automata with output. We saw the Moore machine and Mealy machine and Moore machine. And in the finite automata with output, without output, okay, what is the without output? We saw the DFA and NFA. Today we are going to see the Epsilon NFA and how to convert from Epsilon NFA to normal NFA. So this is about today's topic. So what is the first one? Epsilon NFA. Epsilon NFA. What is Epsilon NFA? Epsilon is nothing but, as I told you, epsilon is a empty symbol. Epsilon is empty symbol. What is the difference between epsilon and phi? What is the difference between epsilon and phi? In epsilon is nothing but, this is a empty symbol and this is also empty string, you can say. Okay, that means epsilon means something is there and some operation can be performed whenever we have the epsilon. When we have the phi, at that time you cannot perform any kind of operation. Okay, this is a difference between epsilon and phi. Phi is nothing but this is also empty, epsilon is also empty, but whenever we have the empty symbol with epsilon, that means you can perform some operation. But if you have a phi, that means it will not go any other state. If we have the phi, if we have the epsilon, it will go to one state to another state or same state also itself. So this is a simple difference between epsilon and phi. So as you remember, in the NFA we have the phi tuples. What are the phi tuples? First one is Q, okay, second one is sigma, okay, third one is Q0, and fourth one is lambda, and fifth one is a final state. So Q is number of state, sigma is number of symbols, okay, how many symbols are there, that will be defined in sigma. Q0 is the initial state, F is a final state. And the slight difference between the normal NFA and epsilon NFA is delta. Okay, let's see here. I hope you remember, in NFA what we will say, whenever delta is Q cross sigma, so what the answer we will get? 2 to the power of Q. This is regular NFA. When we come to the epsilon NFA, when you come to the epsilon NFA, here you can same thing, I will write with the different color. Delta Q cross sigma, okay, Q cross sigma, and here one thing is added, that is union epsilon, and the answer will get Q to the power of 2 to the power of Q. So here the simple difference is, it is added this one small difference between regular NFA in epsilon NFA. What does it mean? Whenever Q is on some input, then we will get some this output. If you have Q on some input, or if you don't have any input also, if you have epsilon, that time also you will get the output. Is this mean epsilon? Okay. So here when I take the example, then you can easily understand this. Like, take the example, I am going to take like A, B, I am taking 3 state A, B and C, 1, 2, 3. Okay. Here this is A is my initial state and C is my final state. Okay. So here when from A to B is going, I am going with epsilon, and B to C I am going with epsilon. Okay. And here the 0 and here the 1 and here 0 comma 1. So this is a simple example for epsilon NFA. How will you differentiate between NFA or epsilon NFA? This is a difference. What is this? From A it is epsilon is going to the next state, from B it is epsilon is going to the next state. So here in the same way, in the epsilon by default every state on epsilon goes to itself. Means here it is not written here, this is also epsilon, this is also epsilon, this is also epsilon. What does it mean of every state on epsilon goes to itself? That means every state has something, like you can write here comma, okay, 0 comma epsilon. Like this it is telling every state is on epsilon goes to itself. So this is the main important thing. So once again I will tell you, in the finite automata without output is epsilon NFA, and here epsilon NFA, epsilon is nothing but is an empty string or empty symbol. What is the difference between epsilon and the phi is, epsilon means if whenever we have a epsilon it will go to itself, or if it is epsilon then it will go to next state also. But in the phi, whenever we get the phi, we cannot perform any kind of operation on the phi. So remember this thing, that is also empty and this is also empty. Here you can say null. Okay. NFA has the phi tuples. If you remember, Q in the previous classes already we discussed, Q is a number of states, sigma is number of symbols, and Q0 is the initial state, and delta final state is F. Only the slight difference is delta. In the regular expression, in the regular NFA, we will have delta Q cross sigma is getting 2 to the power of Q. But in the epsilon NFA is delta Q cross sigma union epsilon, then also we will get the 2 to the power of Q. That means if there is no input, if only has the epsilon, at that time also we will get the output. So this is a simple example for the epsilon NFA. So A, B, C, from A to B there is no any sigma input, okay, there is no 0 and 1, but with the help of epsilon is moving from one state to another state. So in the epsilon NFA, remember every state on epsilon goes to itself. So this is about epsilon NFA. Now we will see, we will take this same example, with this same example, and we will do the conversion of epsilon NFA to regular NFA. So now we need to do this one. Okay. So we will take this same example for solving the problem. So here the basic thing for this is, first you can say syntax or rules. Rule. First rule is state, okay, state, and here we need to take the epsilon star means closure, then we will take the input, then we will take the again epsilon closure. So here this is a thing, first epsilon closure, then input, whatever the input 0 or 1, after that epsilon closure, and here the state. So this is a rule, important rule, okay, important rule. Based on this we can design the state table. Okay, so how the state table can be defined with this graph, this state, okay, how to do that? So I will do one thing. I will take this and okay, so our input is, based on this we need to make a table. Fine. So how many states we have? A, B and C. So A, B and C. A, B, C. Okay, and here 0 and 1. We have the input 0 and 1. But whenever we have a epsilon, we need to perform this operation, this rule we need to perform and need to add in this state table. So first one, what is the state? First state is A. So take the initial state A. Take the initial state is A. It's very low. Okay. So first take the A. What is the state here? A, and epsilon closure, and here the input. What is the input now? What is the input we have? We are going on 0. Then epsilon closure. So here A on epsilon closure, what does it mean? Means with this graph where A is going to itself, as I told you, if A is every state is on epsilon is going to itself. So A is going on epsilon is A, and A is on epsilon is going to B, and B from B epsilon is going to C. That means when the A epsilon is there, it is going to B as well as C. So, here we will get A, B and C, because from A to A is going and A to B is going on epsilon and B to C is going to epsilon. So, this is first step. Next, A on 0, where it is going A on 0, A on 0 is going to A only, A on 0 is going to A only. Next, B on 0, where it is going is nothing. So, here it will be phi. Okay. Next, C on 0, where it is going to C only. So, this is we got the output. Then again we need to do epsilon star. So, here as just now I told you, when A on epsilon is going to A is going to B and C. So, here write A comma B comma C, and B on phi nothing, empty. C on C, epsilon. What is the epsilon now? C on C is C only. Okay. So, this is a main, we got it, and from here A comma B comma C and C. So, here you need to take A on 0, is going to A comma B comma C, A comma B comma C when A on 0. In the same way we need to do the next one, A, then epsilon and 0, same thing, epsilon closure IP. And what is the IP now? We have input is 1 and here epsilon star. So, what is the A epsilon? As I told you, ABC, ABC, ABC. Here from A on 1, where it is going, A is nothing. So, here the answer will be phi. Next, B on 1, is going to B only, B on 1 is going to B only. Next, C on 1, is going to C only, C. Next, A on phi is nothing, B on B, what is a B on epsilon closure? Here B on epsilon closure means B is going with epsilon only, B itself, and B on epsilon is going to C. So, what is the answer here? B comma C, B comma C, because B is going on epsilon the same itself and B on epsilon is going to C. So, answer is B comma C. And what is the C epsilon is itself C only. So, on A on 1, what the answer we are getting? B comma C, B comma C, B comma C, we got it. In the same way, we need to do for the B. B epsilon closure input and epsilon closure. What is the input now? We are taking 0. First B on 0. So, take B closure. What is a B closure? Already we got it here. That is B and C, and B and C. And what is B on 0? B on 0 is phi, is not going any, sorry, Yes, B on phi, this B does not have 0, so B on 0 is phi, C on 0 is going to C. So this is empty, and what is the C closure? Already we found here, that is C only. So the answer here we will get C. B on 0, we got the answer C. Next, same method, whatever I applied here, the same method I am applying here. B on epsilon closure input, that is, what is the input now? Now input is 1 epsilon closure. So here B on what is the epsilon of B? Already we found it, B comma C means BC, because epsilon for the B and epsilon, it's after taking epsilon is going to C. B on 1, where it is going? B on 1 is going to 1 only, sorry, on B only. B on 1 is going to B, and C on 1 is going to C. C on 1 is going to C. So here B on 1 is going to B. So B, what is the B closure now? B closure is, already we found it, we got the answer B comma C, and here we will got the C. So what is B on 1? B on 1, B on 1, what the answer we are getting? B comma C. B comma C. In the same way we need to do for the C also. Let's do it. C epsilon closure input epsilon closure. So what is the input now here? Our input is 0. So here epsilon, C epsilon is C only, because it is going to itself only, and C on 0, what the answer we are getting? What the answer we are getting? C on 0 is C only, and what is the C closure again? C. So here answer we will get C. Next, in the same way, C on epsilon closure input epsilon closure. So here what is the input now? 1. C epsilon closure is C. C on 1 is going to C. C. So here answer what we are getting? We are getting the C only. So this is a table, transition table. Okay, based on this transition table we need to draw the state graph. Okay, how to draw this? First thing is, you have to take state A and take the B and take the C. Take the C, A, B and C. Okay. First, A on 0, where it is going to A, B and C. A on 0 is going to A and is going to B and is going to C also. When A on 0 is going to A, B and C, is A on 0 is going to B, A on 0 is going to C. Next, A on 1 is going to B. So you can write the comma here and you can write comma 1, okay, comma 1, and A on 1 is going to C. A comma 1, A on 1 is going to C. So this is we finish A. Next, B on 0 is going to C, and B on 1 is going to BC. B on 1 is going to BC means, first B on 1 and 0 comma 1. Okay. Why I am writing 1 is C. Next, C on 0 is going to C and C on 1 is going to C only, 0 comma 1. So this is the answer, epsilon with NFA to normal NFA. So this is the answer. We got it. 0 A on 0, A on 0 comma 1, B on 1 is going to C as well as B. Okay, and C on 0 and 1 is going to itself. So we remove the epsilon from this state table. From this state table we remove the epsilon and we conversion from ENFA to NFA. I will quickly summarize this. Conversion of epsilon NFA to NFA. What is the main important thing? First, we have the state diagram. In this state diagram, you need to implement this condition and this rule, and you need to create the state table. So here, first A, what is the state? First one is A state, epsilon closure, input epsilon closure. So epsilon closure is A epsilon closure is, what is A epsilon? Epsilon means from A while taking the epsilon where it is going. When A on epsilon where it is going, A on epsilon first is going to itself and A epsilon is going to B, then from B to C is going to with epsilon. So A, B and C, these three are the epsilon. So A, B and C, I wrote it, A, B, C. Next, A on 0, what is the output? A on 0, we are getting A only. Next, B on 0, we don't have 0, so because of that phi. C on 0 is going to C only. Okay, so this is, we completed the input. Next, what is the A closure? A closure, just now I told you A, B, C, just now we got it. That means from A with the help of epsilon where it will go. So A by default it will be itself, epsilon by itself. Okay, if any other epsilon is there, you need to consider that. A on epsilon is A on epsilon is B, and B on epsilon C. With the help of on epsilon, it's going from A to C. So A comma B comma C. Next, B on phi, we don't need to do anything. C on C closure. What is C closure? On epsilon, only C is going to itself. This is by default. In the same way, A closure. What is the A closure? Just now I told you ABC. Okay, and A on 1, where it is going is not going anywhere. Because of that is phi. Then B on 1 is going to B only, and C on 1 is going to C only. So B on 1 is B. What is the B closure? B is going itself on epsilon, then as well as is going to C also. So B comma C. Next, C on C closure. What is C closure? Only C only. So it's the answer. Next, B on epsilon star. What is B? Just now we did here BC. We got the B and C. Then B on 0, we don't have anything, is phi. B on 1, sorry, then C on 0 is going to C only. So we will not perform any operation here. He will, because it is phi. So C on epsilon, where it is going to C only. Next, B on epsilon star. Okay, B on 1 is going to B, and B on C on 1 is going to C. Next, epsilon is B comma C, B comma C, already we did here, B comma C, and C on 1 already we got it C, and C epsilon is C, epsilon. And what is the last one? Last one is C. C epsilon is C, and C on 0 is, answer is, as per this table we are getting the C only. C epsilon star is going to C only. So in the same way with the 0 input and with the 1 input we got this, and we added in here. Okay. So after preparing the state table, we need to draw the state graph. Based on this, I have 4 states A, B, C. A on 0 is A comma B comma C, means A 0, B 0, A C is 0. Next, A on 1 is going to B C, A on 1 is going to B, A on 1 is going to C. In the same way, B on 0 is C, and B on 1 is going to B comma C. B on 0 is going to C, and B on 1 is going to B as well as C. And here we will see the C. In the C on 0 is going to C, and C on 1 is going only C. So this is your final answer without, after removing the epsilon, conversion from epsilon NFA to regular NFA. So thank you very much. We will see in the next class.